Hi everybody, in this video today we're going to be talking about converting equations over to standard form that are quadratics. So we have learned about vertex form and factored form and standard form, and each one of those has its advantages and disadvantages. So sometimes maybe standard form is the best way to go, and so we're going to talk about how to change over from those other two over to standard form. Now before we do that though, we have to get into some basics, and that is a little bit of review from your previous years, either Algebra 1 or Geometry. You should have worked on multiplying binomials. Some teachers call this FOIL. I like to call it double distributing. And so what we do in double distributing is we have a binomial, that is there's two terms, times a binomial, two terms, and I'm going to multiply each item inside here times the other two. So I'm going to distribute my n, and I'm also going to distribute my 5. Okay, so that's how I'm going to go about that. So I'm going to start off with that n and focus in on that part of it. And so when I do that, n times n is n squared, and n times 2 is 2n. Now I go to the other one, and I say 5n and 10, because of 5 times 2. Now remember that you can you can combine like terms. So I'm going to combine those like terms, and I'm going to get n squared plus 7n plus 10. And that's my final answer. All right, that was an easier problem because it had all positives in it. This one is a little bit more difficult, not really, but it does have a negative, so we just have to pay attention to that negative sign. So we're going to get y squared minus 7y, but then when I do these, I get plus 4y and minus 48. Excuse me, minus 28. And again, I want to combine my like terms. And so I get y squared minus 3y minus 28. All right, those were pretty basic because the first term on each of those was just an n or a y. These have a coefficient. We just have to remember that we have to include that coefficient and multiply it also. So that's going to be a 6c squared minus 16c. And then we go to these two, and I get 15c and minus 40. And once again, I have to combine my like terms. And in this case, my two middle terms was a negative 16c and a plus 15c. That just adds up to a negative c. Now remember that when we have something taken to a power of 2, that means times itself, right? And so what I'm really doing on this problem is I'm taking v plus 3 times v plus 3. Now I'm going to do the same thing with my double distributing. So I'm going to get v squared plus 3v, and then the other one, another 3v plus a 9. So I just multiplied those, and then I multiplied those. And once again, I have to add my two like terms together, and that gives me a 6v for my middle term. All right, these next two are sort of special cases. Something pretty cool happens with this second one, or the number 5. So let's just take a look. We're going to double distribute as always. It gives us x squared minus 5x, and then when I distribute this one, I get a plus 5x minus 25. Now the cool part is the minus 5x and the plus 5x, they cancel each other out, which may or may not impress you, not sure, but we get x squared minus 25 for that. And then the last one, once again, when we have something to a second power, that means multiply it times itself. So I'm going to rewrite it out. You can probably do that in your head without rewriting it, but I'm just rewriting it so that we can see how to do it. All right, and then again, we are going to double distribute. Okay, so we get a 4y squared minus 14w, and then another minus 14w, and then a plus 49, because negative times negative is positive. Now, just remember that on this previous one, they dropped off because one was negative and one was positive. In this case, they're both negative, so it's not going to drop off. So instead of dropping off, they actually add up to a negative 28w. Okay, that is a skill that you should have learned in Algebra 1 and maybe even used it in Geometry, and we're going to use it a lot in this unit. I mean a lot. We're going to use it every day, might not be an exaggeration. So let's start off with what we're going to do. So when we have something in factored form, remember factored form, if we were going to graph this, we would know very quickly that factored form gives us a negative 1 intercept and another x-intercept at positive 3. That was really, really fast and easy. But that's all, as far as looking at it, that's all we can get. All the rest of it has to be some math in some way. And maybe standard form can give us some more pieces of our puzzle. So what I'm going to do is I'm going to multiply this out. What I like to do is keep my -2 separate for now and bring it in later. So I'm just going to bring those down and just let that hang out here for a minute while I take care of my binomials. So I'm going to multiply these together. So I'm going to get x squared minus 3x, and I do this one, I get a positive 1x and a minus 3. I need to simplify those. And so my middle two terms add together give me a -2x, and I still have that minus 3 there. Okay, now I'm going to distribute that -2. So now I'm going to have to take that -2 and multiply it by all three of them. And so my final answer here is going to come out to be a -2x squared plus 4x plus 6. And so that is now in standard form. Okay, I had to kind of sneak in some writing here. So my new standard form is f of x equals -2x squared plus 4x plus 6. Well, what did that gain me? Why do I even bother? Well, one thing it gained me is it gave me my c value, right? Standard form, that's what standard form is so great about, is it gives you what your y-intercept is. And so now it's going to be quite easy for me to graph this. So I'm just going to come down here for a second. I know that I have one at -1, 0. That I got from factored form. I also know I have one at 3, 0. Also got that from factored form. Now I also know I have one at 0, 6. And I got that from my standard form, and that's a 0. That was just messy. That's a 0. So 0, 6. So now I can really easily do my graphing, I hope. So one thing is, remember, when you have these two intercepts, you can find your axis of symmetry. You count to the middle, or you average them together, and it gives you your axis of symmetry. And this point does reflect over. And if so, then this 6 should also reflect over, which it does. And I know that I have a 1, 3, 5 rule, but my 1, 3, 5 rule is being multiplied by 2. So I'm going to come up here, and there is my vertex. So I didn't actually have to do any math, like any plugging in numbers or whatever, to do that. And even if we want to have one more point, we actually have space for one more point here. Let me show you that just a second. Okay, remember we talked about this odd number rule, that we always go up by 1, and then by 3, and then by 5. But this time we have a -2 in front of it, which means that we're going to go up by -2, -6, and -10. Well, I said up by negative, that's kind of weird. But what that means is we're going to go down 2, down 6, and then we're going to go down 10. So if you actually wanted one more point on your graph, you could easily get that. All right, this table is for, just a reminder, you can always use a table of values if you need to. I don't think we need to on this one. I think we know how to do this without a table of values. The main thing here is don't distribute the same term twice. In other words, remember how I kept that -2 outside here? Some people, what they do is and this is wrong, so don't do it, but what they do is they distribute times this, and this, and this, and this. But then when they distribute this, what they're actually doing is distributing that -2 too many times. They're going to actually multiply times -4 or +4 instead of a -2. So don't do that. Don't multiply it out too many times. And like I said, I think the best way to avoid that is just by keeping that -2 out while you deal with these, and then do that one at the end. And so that's this note here. Don't distribute the same term twice. Okay, vertex to standard form is really going to be just almost the exact same thing. One thing that is missing here, and maybe I'll add it so that it makes just another level of complexity maybe, which we would want in an example. Let's say this has like a +3 on the end, okay? Because that's gonna be a better example for us. What do we do first? PEMDAS says go inside and do the exponents first. So I need to focus my attention right here at the very beginning. So back to that, just bring stuff down and hold it aside for a minute. That's what I'm going to do here. I'm focusing my attention here, so that is to the second power. That means I multiply it times itself. I can already tell I'm going to run out of space, but I'm just going to fit what I can in here. So I'm going to multiply, like I said at the beginning, I'm going to keep these, I'm going to multiply these together first, and then I'll deal with the other stuff. Okay, so I brought down my h of x equals 1/2, and I brought down my plus 3, and I multiplied this stuff as my first step here. Now, some of you can probably do that without showing, well, let me show you my next step, because we need to combine those terms. So I had to combine the negative 4x and negative 4x be negative 8x. And that's what I'm saying. If you don't have to show this step because you know that those two combine, you can do that. That's okay. I was just showing my work because we are learning about it. Okay, back to PEMDAS. PEMDAS says multiply first, or even exponents. Did that. Now that we've done that, there's another multiplication here. Remember, this 1/2 is 1/2 times. So I do need to multiply that 1/2 next. And so I get 1/2 x squared minus 4x plus 8. And then I closed my parentheses because that 1/2 does not get distributed to the 3. It's just the 1/2 times this stuff. Okay, so then I close my parentheses and have a plus 3. Now PEMDAS says at the very end, let's add and subtract. So now I'm going to put that 8 plus 3. All right, so now I get this as my final answer, 1/2 x squared minus 4x plus 11, because I put my 8 and 3 together to get 11. All right, what did this gain us? Well, let's look at a couple things on the graph. From the original, we knew that the vertex was at 4, 3. So I'm going to go to 4, 3 and plot my vertex. And if that's my vertex, then I know my axis of symmetry is there as well. This form told me that I have an intercept at 11, a y-intercept at 11. So it's a little bit off my graph, but I'm just going to put it right here. And if I have it there, that is 4 boxes over, so I can go 4 boxes over and have another one here. Okay, now my odd number rule is now multiplied by 1/2. So now I know I'm going to go from my vertex up 1/2 and over 1, up 3/2 or 1.5 and over 1, and so forth. But look, I have these up here that are going to help guide me. So like if I'm not so good at counting by fractions on my graph, I've got these as well. And so now those help me to fill in my parabola like this. So the deal is, when you have a couple things, when you have this vertex form, you have to follow PEMDAS. You have to multiply the exponents first, do that first, do your adding and subtracting at the end, and then you have two different forms, one in vertex form, one in standard form, that can help you graph the graph. Okay, a couple things that you can write down in your summary. You only distribute one time. Follow your order of operations. And each form has advantages. If we can convert between forms, then we've access to more advantages. Makes it easier to graph. And then again, this thing about only distributing once, that's the part that people get stuck on. So keep that leading coefficient off to the side and just bring it down, and don't deal with it until after you've dealt with those parentheses. Okay, hopefully this can help us learn how to graph a little bit better because we have multiple forms.